So, we're in NDC Oslo. My name is Andrea Magnorsky, and I've been a developer for like a ridiculous amount of time in my experience. Because I suffered being a developer for a very long time, like maybe 15, 16 years, which is a significant part of my life. You're like, yeah, I've done the same, exactly. That's more or less what we're going to be talking about. So, in this picture you see here, this is a party with animals. And these animals are like, woo, great, we're in a party and it's great. So why do I have this picture here? It's very confusing. Well, we're going to be talking about the paradigms of programming languages and the problems you see when you use these different paradigms in the different programming languages. And I kind of equated this to a party because there's all this, in a party you generally have like a friend that is like one way, a friend that does regex, right? That we all have a friend that does regex. You have some other stuff, or friends that like dressing up. So it's kind of like very diverse thing. These are the programming languages. So there are some disclaimers. When we talk about any of this stuff, generally there's when someone says something like, FRP is definitely the tool for doing GUI programming. There is a bunch of context attached to that. And obviously, based on your context, you'd see different things. So in this typical elephant example, all these people that are touching the elephant are blind and are looking at this and going like, this elephant is kind of like a tree. If you don't have the context of that person, everything goes to the toilet. So really important, and everything I say here. So basically, if you catch me saying something that you don't agree with, is because probably I have some different context. Another problem, this is all the disclaimers before I actually start. I am Irish, and so I say a bunch of things that sound weird sometimes, so I just thought that I'd just give you the heads up. So if I say, it's for the crack, I don't mean the drugs. I mean, it's fun, etc. Anyway, now that we're all ready, I think. This is Bacon. I am really, really happy that Bacon was actually able to join me here. Bacon is a developer as well. He's been delivering software for like 15 years. This is really interesting. He's very excited to be here. Bacon has delivered production software in Delphi, Visual Basic.NET, and VB6, C#, Java, JavaScript when jQuery was new. Remember those times? Right? So he did some GWT as well. He did some Fsharp. This is when he started learning about functional programming, and he got really excited. Yeah, because it's like, oh my God, all these problems that I'm not gonna have anymore, and it's great. Then he did some Scala, right? So it's like he had to learn all this new JVM stuff, and slightly different, but kind of the same. Very excited. So he started learning about these things that you get with functional programming, right? You get like, oh, I'm now thinking about referential transparency, which is that thing that basically makes you think, great, I'm going to replace this expression with a value, and the program still works the way it used to. So when you start thinking about that, there's a bunch of side effects that come out of that, which are, for example, writing concurrent code is easier, and stuff like that. With functional programming, you tend to do stuff with immutable data structures, meaning that, again, a lot of problems kind of just go away. It is a little bit of a trick to learn how to do it, but it's really good. So no exceptions for flow control. So basically what you do, instead of going like, I have an error, no, we don't do that anymore. We deal with it with types, or maybe we deal with it a different way. There's all this stuff. So Bacon here, this is not me, obviously. This is Bacon, the squirrel that I just introduced you to it. So Bacon is really excited about this stuff, and he starts tweeting about this stuff, and he tweets sometimes stuff like this. And the thing is, like, Bacon has a few friends, and the problem is that Bacon's friends didn't feel very good about this because, well, that's, from their point of view, Bacon is kind of like a bit of an idiot, right? He's kind of doing this thing of like saying, hey, this new thing is great, which implies a little bit of like, hey, the thing that I was doing before that you're doing is not. And that is not good. So let's try to dig deep into Bacon's thing a little bit, right? So when Bacon says FP, or functional programming, he talks about type functional programming. So because his experience comes from Fsharp and Scala, right? So that has a bunch of context about that, right? So that means that you have the safety of types and you want to prove things, and Bacon wants to do FP everywhere. None of this, half-baked using of some aspects of FP. He wants to, all the way through the whole program, the whole system should be FP. This is what he wants. And he aspires to purity in functions. So purity means that for every time that you put an input into a function, whatever that input is, the output will always be the same. So no side effects. He also wants total functions, even better than purity. That's something that is completely constrained. He doesn't always achieve this purity and/or function totality because it's actually quite hard. Not all problems lend themselves to this. And also, when you're dealing with functional code and you're dealing with a language or a platform that allows you for 2 or more paradigms, these two things tend to not work really well together. So the way we generally deal with that is by writing wrappers. Examples of wrappers. There's aka.net, that works really well in C#. If we want to use it in Fsharp, there is a bit of a wrapper there. The wrapper is really good. Trick is, to write a really good wrapper is difficult. So what we know about that is, so you need someone really experienced in the language, in something that is highly used, and the thing with this is that it doesn't actually scale, right? Because, well, it's just, this is one library. What about all the other libraries? The reason we're using Fsharp or Scala is because, oh, great, I'm using this functional language, and I get the benefit of all these libraries already working. And sometimes you need to use these libraries. Like, for example, if you're doing Fsharp and you want to do web stuff, you have Henrik Suave framework, Suave, right? And but the thing is, like, you not always have a native way to do this, and that, how does that work? So that's what Bacon's context of FP is. Now, Bacon didn't actually word this up correctly. He didn't tell a bunch of his friends about this, but this is what he's thinking. He thinks that there's some problems with FP, especially in Scala, for stuff like dependency management, trying to get your dependencies in and, actually having something running. It's a little bit trickier than you'd like. It's a little bit easier in Fsharp, I think. But in Scala, you have, that I know, at least 8 different dependency management libraries. The approaches ranges from reader monad to constructor injection, and it feels like a little bit too much effort. Why do you have to do this? This thing is something that we do all the time. Who does some sort of dependency injection-y thing? Who needs dependencies in their programs? Literally everybody, right? So why isn't that built into the language? Then he has to do a lot of type tetris. So most typed FP, all these languages have higher or slightly more complicated type things, right? So you have to think about types a little bit more. This means that eventually you have to kind of play a bit of Tetris, because it's kind of nice to think of types as some sort of bag of things that sometimes they have a nice shape, and you kind of need to, plug them in. So you kind of wind up doing some type Tetris, and that can be complicated. Then there is some other complicated concepts. I'm totally trying to sell you FP, by the way, but it sounds like I'm not, but there's a trick. Also, this is Bacon's version, right? So there's some more complicated concepts. Once you start learning about Fsharp or Scala or or Haskell, there's some really, really complicated concepts, and the more you dig, there's more, because this thing comes from maths, right? Okay. So, for example, monad transformers. Do we actually need this to write some programs? It's kind of complicated. In reality, the reason why Bacon came into all this stuff, into trying to do FP, and why he is so excited about it, is because he has this dream. It's well-structured software. And it turns out that it's not easy to write well-structured software, because, well, good things are not that easy. So I'm going to be quoting a bunch of papers as I go, and this is a very nice one. And this is by John Hughes, and the paper is called "Why Functional Programming Matters." John Hughes is the same guy that wrote Quick Check with some other stuff. If you missed out on Romeo talk, you can watch it online. He did a talk on property testing. Probably really exciting and good if you like testing. So that's Bacon. This is what he thought about stuff. But now you get to meet, it's an owl, right? So is also very excited to be here. Yeah, aren't you? Yeah, great. And Bacon are good friends. They work together. However, for for her, performance is the reason why she codes. She learned to program in C when she was like -3 years old, right? It's like she was born and going like, oh my God, I love this stuff. At the same time, she's been, working with Bacon, sometimes let's call it suffering Bacon, and she's kind of curious about this stuff, but she doesn't buy in, maybe because Bacon never told her about these problems, but these problems that we talked about a little bit before, still, something doesn't click, something didn't really work. So, that's the noise I got. That's her name. It's been reading this really cool ACMQ magazine where Odersky, the creator of Scala, was talking about functional programming. I'm assuming you're reading, so I don't have to read up. So when I put something there, read it, which is nice. And it's like, you can get this parallelism and distribution kind of for free. And it's like, okay, that's, this sounds great, because they have to write a lot of stuff that runs in many computers and no errors and everything's cool. Especially for Scala, this disparate programming language philosophies, right? Now, this is the impact there is like, please. So Odersky is promising us, we're trying to buy into this amazing thing with, in one programming language, you get the power of OO and the power of FP, like, which is kind of interesting. So, who is listening? And also, who knows what solid in OO? Okay, the solid principles, single responsibility, help, open close principles. Someone else, it's not fair. Dependency inversion, we're nearly there. What? Interface segregation, we have to do. List of substitution principle, great. So when you do all of those things in something like C# or Java, right? And you squint, this kind of start totally looking like functional programming, because when you get SRP all the way to the end, it kind of looks like a bunch of functions. So that's kind of interesting. You kind of get on over there. The reality is that and Bacon, although they're good friends, out of work, in work sometimes they really want to kill each other. So that's one tension. I don't know if you've seen it, but when you, for example, even today during the keynote, Dylan said something like, you don't feel bad if you don't know Fsharp, or something along those lines, because it's like difficult or something. It's like, this is a tension. It's like, why are we even doing that? So that's one thing. This is and Bacon. Now let's see, what do the creators of Scala and Fsharp actually think? Because it's like, this is their life and their reality. But Don Syme in 2009, which is it sounds like really, really long time ago, basically said this. So basically, he's saying, Odersky created Scala to replace Java because, up until very recently, Java was not being updated at all, and replacing it was an extremely good idea. Where when Don Sam was creating Fsharp, he was like, okay, .NET is actually pretty all right at component management. So what we can do is do Fsharp as in functional first in the small and objects at large. So when you have to do componentizing things, doing it in a .NET way is totally okay, and it's the way that I see it working. So this is Don Sam creating Fsharp and saying this. So he's saying multi-paradigm programming, totally cool. So what about Odersky? Well, we know about this stuff because I just put this a little bit before. The key lesson in these philosophies is that these philosophies do not need to contradict in practice. At the same time, I don't know if some of you have done C++. Exactly, okay. So you'll recognize this maybe a little bit, this responsibility thing, and having people actually know, and someone novice to the language might need some guidance. This statement is something that we probably need to come back to, because the thing that I'm interested in here is, do this ability to implement the two paradigms, do they overlap with each other? Or how do you actually deal with these two things? Because if you're writing kind of Scala or Fsharp, how does it work when you need to also write Scala or Fsharp FB? How do you make it work within yourself, and how do you make it work in a team? That's even harder. So probably we need to do something about that. Generally, the way you deal with that, at least C++ has a bunch of idioms. Do we have those in these languages? So basically, Odersky and Syme agree that multi-paradigm programming is the way to go, and that we can live together in some sort of harmony. The reality is that these guys have fights. So we have the fights that they have, and the fact that they fight with kind of, and I'm doing air quotes, fight with Syme and Odersky. We have another tension in this, which is a tension that was born, as far as I can see, very long time ago. This is Alonzo Church, the creator of the lambda calculus, and Turing, Turing machine. So the first time or in about 1928, Hilbert had he talked about he kind of exposed a bunch of problems, and then one of those problems was called the Entscheidung problem. Sorry to people that speak German, and this is like the decision problem. And when he asked this question, like parentheses on history because I can tell you about it later. At that time, these two people came up with something to try to help answer that question, and Church came with the lambda calculus a little bit after Turing came back with the Turing machine. Now, these two solutions Turing's solution feels, even though it's well-reasoned and very good, it feels like more pragmatic, more hands-on, more grown. Alonzo Church's answer feels like more reasoned, more sciencey, maybe more engineered. That same kind of tension is something that if you think about something like Alan Kay's Smalltalk would be on the organically grown, based on experiments and trying to come up with something new and fresh, versus something like Dijkstra, again, very reasoned, etc. I'm sure maybe that you have your own friends and people that you think about, and you see these two things. You have your hacker friend that does this crazy thing, and you kind of don't really agree with the way they do things, but maybe they come up with like some amazing solutions that you wouldn't have thought of. But also you have your super nerd friend that's trying to go and find out and actually read all the 50 million papers and actually come up with like this other thing that maybe you didn't think about. So it's like these two tensions. So now you have three sets of how things are working, right? You have the practitioners, the academics, and actually just people being themselves, which is kind of confusing. But at the end, we're all writing software, and we need languages, we need tools, and we need people that we're either writing software to or writing software with or for, and those people give you like loads. That context is kind of that thing that makes everything kind of make sense, and that if we don't have that, it doesn't matter who you're talking to. So with all these problems that we have, we might have questions about, you know, how should we interact with these paradigms, and these paradigms shift, right? So, you know, Bacon has been here for a while, and while he was doing Fsharp and C#, he saw a bunch of people discussing this thing and talking past each other. You go back to Scala and you say similar fights minus the syntax problems. So maybe we have some sort of historical thing where this happened before. For example, like a few years ago, doing object-oriented programming was a terrible idea. We all know that, right? And before that, there was something else that was terrible. Before that, there was like just science. You know, it's like people believed that the Earth was flat, that, you know, there was a thing called phlogiston or something like that, that oxidized things. So, you know, how are we going to deal with that? Maybe this history can teach us about what are we going to do, which is nice. So I propose this. Right now, I'm going to show you this paper, or a bit of this paper, which is called Programming Paradigms for Dummies, from Peter Van Roy. So in this paper, he went over and distilled how paradigms relate to each other in this amazing diagram. Now, I don't know you, but I always kind of thought that there was like a handful of paradigms, but there is like 37. That's quite more than I expected. So if you examine this diagram in detail, you will find that, you know, they are organized from more declarative to less declarative. Then there is like, are they more deterministic or not? This is a great way to think about this. And when you see the diagrams, you know the way that there's little arrows on the side when it says, for example, plus cell state, you get Pascal. So if you just do FP, like at the very top, which is like functional programming first order, and you do plus cell state, you get imperative programming, right? So I don't know why that state thing is there, by the way, but what I'm trying to show you, the way this came about is he organized the programming languages based on records, lexical scope, closures, independence, which actually means concurrency, and namestate. So what I'm trying to show you by this is that basically Peter Van Roy analyzed a bunch of programming languages, and removed a key element, which is the people, to be able to come up with this as a way to logically organize this. In the middle of all that, he found, with his team obviously, stuff like this. We actually need many paradigms to come up with solutions. I mean, we could have other slightly lesser solutions, but you get a lot of bang for your buck when you look at these different paradigms. He also found that, ideally, a language should support many paradigms, and that it shouldn't be encumbered by the others. So you know when I was saying about Scala and how we don't have idioms yet, maybe for doing multi-paradigm programming languages, he's saying that we should probably have a way to deal with that is a little bit more organized. Most importantly, there's certainly not best paradigm, because solutions are, you know, when you're doing FP for a while, you can get maybe like Bacon. You're like, FP, totally the best. Maybe when you started doing OO, you were like, oh, totally the best. And next time when you do something else, you'd be like, this sort of thing, totally the best. We always want silver bullets as developers, and I'm totally guilty of that myself when I get excited about something, but it's good to catch yourself up and go like, okay, just calm down. So that is this thing about paradigms of programming languages condensed, right? So this guy over here in the back of that picture, his name is Thomas Kuhn. He wrote a book called The Structure of Scientific Revolutions. And this text here is the description of the crisis, right? So in this book about the structure of scientific revolutions, he basically explained how some community changed from how he used to think to how he's thinking, how they think now. That thing doesn't just happen. It's not like, hey, I discovered, faster than light transport, woo! And everybody goes like, oh my God, I totally believe you, Andrea, this is great. That's not how it happens. The way it happens is there's a bunch of work, a bunch of people get it totally wrong, a bunch of people advance this by a little bit. People are kind of thinking, it's about time we have faster than light travel. And then someone actually finds the ultimate bit of the thing that was missing, and then suddenly everybody goes like, right. But for that to happen, you needed some sort of crisis. People going like, wait, are we doing everything wrong? We need to philosophize about this and, find ourselves again. And then someone does it, and then it's like, oh, but actually it wasn't him or her. It was like this other guy at the same time. And then there's this thing about how we love having one person discovering things, and not how it happens anyway. Generally, there's a momentum and stuff. So this description, this crisis, is generally resolved by a revolutionary change, which could be, in this case, faster than light for my obviously fake example. So this is happening now, right? C++, the quintessential longest running thing that runs systems everywhere, except for Fortran, actually. It's adding lambdas. In fact, right after this talk, there's a talk on functional features for C++ in version 17. You should totally go to that. So we're getting all this stuff. Link, wonderful thing. Started added to Fsharp like many years ago. Who doesn't love Link? And it has so many aspects of functional programming, and it's working. So are we in a functional programming revolution yet? And I'm asking this question because this is where you see this reaction, right? You kind of go like, well, when you accept that when a revolution happens, you need to switch your mind to believe this other paradigm is better. As a human, you have a trip on like, before you believe something, and then you believe something else. And that is a thing that you do as a person. And the moment you realize that other thing is better, air quotes better, that moment you also kind of go like, oh, I can't believe the previous thing that I believed before because it doesn't make any sense, right? So even though multi-paradigm programming is all well and good, according to what it should be without the people, you as a person contradict this because that's human nature, I think. So we start thinking about this, which is philosophizing. The most important thing here, I think, is this thing that once you change your mind about, new thing, functional programming maybe, or logic programming, or in fact you were a functional programming and discovered, oh whoa, because that can totally happen. Suddenly, you can't talk to each other anymore because you're talking about slightly different things. You kind of go like, oh, but I love oranges. And it's like, no, apples are the best. It's like, but you're literally talking about different things, which is not great. And this happens. So, and this is all from, this is not something that, that we just kind of thought and it's nice. This is a guy that wrote a book about history of science, and this happened like 1 million times, right? Who likes Battlestar Galactica? Great, you're gonna like this. For those of you that don't watch Battlestar Galactica, this is a really good series on, obviously, sci-fi. For those of you that haven't watched it, you will hear this quite a bit if you do watch it. If all of this is happening again, right? If we keep coming over and over this similar thing, And then we fight and we dedicate all this time to fighting. Or like you're going like, no, but it's an apple and it's an orange. Maybe we just need to get better at changing, right? I mean, all of us know as programmers that the best thing we can do when something is painful is doing quite a bit. And once we do it quite a bit, we automate it, right? So let's try to kind of get on the boat of like, we need to automate how we think about this a little bit more so that we can change faster and with less pain, which is good. Well, I think it's a good idea anyway. You know, it's like, this is me actually thinking this would be nice. We have a unifying thing in all this change, no matter what we think about. We all struggle with this stuff. We will suffer releases. We will suffer other people's codes, like literally the worst. Our own bugs, bust selves. Terrible. There's no perfect programming language. Even if you make it and it's perfect today, it's going to be terrible tomorrow. So what are we going to do with this? The thing that kind of unifies all of this is the fact that we will build something and it will run in a computer. And that's all. So the first time that we ever heard of a programming language paradigm was in this paper by Floyd. He received the Turing Prize Award in 1978. And he had a bunch of advice about these paradigms. And I really, really like some of these bits. This first one that you see here is about familiarity. He's saying, please, 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 if you're writing a new language, there is like thousands and thousands of languages, give me some patterns that I can hold on to. I need some familiarity if you want me to do something useful with this. So we're trying to find patterns. You know, and not necessarily, it's patterns in the sense of like, don't think about the kind of formal patterns, although they are patterns too. It's like, these are just like repeatable steps that I can use so that I can get something done. Okay, I'm totally on board on that when it comes to doing something that actually does something. He's saying, hey, if I need to teach something, you know what I need? I need patterns. Because when you're learning something, you need to fake it until you make it, right? Because the language will change. Very few people in our field get to write the same language for like 25 years or 30 years. I don't know how long people's programming lives are, but let's say 30 years-ish. You're not going to write the same language. In fact, you're probably writing many languages at the same time right now. So might as well actually learn what is these patterns that are repeatable on a paradigm by paradigm base. And his last bit of advice, which I totally subscribe to, would be this. Learn something every day. Who doesn't get on board with that? You know what he's trying to do when you learn something every day? If you're learning the same programming language for like a while, you know what you find? Patterns. Because you keep repeating things, saying, oh, wait, we could do this other way. And it's like, maybe you'll get some surprises or not. Read other people's code, find their own patterns. Do they do something different and interesting? So, I'm going to herd all these cats, right? Because I'm going to throw a bunch of stuff at you like this. Listen to this is the paradigm, this is the stuff, right? So, remember how we had a party of animals? Well, we have a party of cats first. So the people are really, really important in this context. So make it your context. When you're writing something, the people that you depend on and the people that you depend on you are really important. Get them on this. Probably the best advice I heard ever is, if you study the past, you will learn something about the future because we don't live in isolation. And the best thing you can do is learn logic programming, learn assembler, learn any kind of different thing that you've never heard of, because you will learn something for today. It doesn't matter that you don't use it You just learn it because it's fun. And finally, the party is programming, and everybody can code. Hopefully more and more people will be coding more, and that means that they'll come home and come to programming with their own sets of crazy ideas that we completely disagree with. But maybe something awesome will come in the middle of all of that. So, oops, that's it. Thank you very much.